Hey guys, uh, let's see what we got for today. So here's what we are gonna talk about today. So first I will speak about cyberspace, then computational paradigm, object-oriented paradigm, anatomy of object, anatomy of class, and then I will introduce unified modeling language or UML, and then I will talk about documenting classes. So all of these stuff will be covered in 2 sessions. Uh, Before going further, we need to be familiar with a new term, which is called entity. Entity is that kind of terms that will be used a lot in computer science. First, let's see if we look it up into dictionary. Um, let's see what we got. So here is the Merriam-Webster definition of the entity. So it is independent or self-contained existence. Something that exists, something that independently exists in this universe, right? Another definition is something that has separate and distinct existence, an objective or conceptual reality. So it means that some things that physically in the universe exist or virtually exists in our mind. So this conceptual reality is referring to that. So here are some synonyms. So it is equivalent thing, something, object, individual, something like that. Okay. So bottom line is entity is something that exists in this universe, physically or conceptually. Let's see what's the definition of the entity in computer science. So in computer science, we don't have any definition for that. I have seen some definition in different sites or even in different dictionaries, but the fact is that we don't have a specific definition for that. Why? Because if you want to define something, you need to use some terms and concepts which is simpler than the term that you want to define, right? For the entity, we don't have such terms, right? So we have to accept that entity is a primitive concept in computer science. Primitive concept is those concepts that we cannot define and we assume that everybody understand what it is, right? And if you want an analogy to other sciences, probably the best example would be the definition of point in geometry. You remember that we couldn't define point, but the whole geometry was based on the point, right? So based on the point, we define the line, and then based on the line, we define the page, and so forth, right? So in computer science, entity is such thing. It means that it is a primitive concept, and we assume that everybody understand that. All right. So let me take some examples for the entity. So for example, human. A human is an entity, a car, airplane, employee, manager, address, monitor, the hardwares, the keyboard, a mouse, memory, a product, a client, a price, an invoice. So you see, we have billions of types of the entity. So these are, based on the dictionary definition, these are those objects that independently exist physically or conceptually. So to sum up, uh, any individual thing that exists in the universe is called an entity. Now let's see what is cyberspace. So we know that we as a human, we are tool maker. We make tools. Why? Because we want to improve our abilities, right? Or we can say equivalently that we can say that we make tools to make up our weaknesses, all right? So one of these tools that we made is computer, and it was supposed to improve our brain, right? Okay, so uh, but after a while, we connected these computers and we created network. Why we did this? At the beginning, we wanted to share data, but after a while, we noticed that we can use this network for communication. All right. And after a while again, we connected these individual networks to make a network of networks, and we call it internet. All right. So this internet connected billions of humans and devices together. We created some societies, some communities, some, regardless of any geographical borders. So this was actually a borderless communities or societies. And billions of the software are running inside this huge network. So some software, some images, audios, videos, books, articles, yeah. And also we have some rules, some ethics, some regulations. So it looks like that it is a universe, right? It is a universe because all of the specification of a universe exist in the internet, right? So let's shorten this long story. It is a virtual universe. It is a virtual universe. It is actually an electronic model of the real universe. And that's the thing that we call it cyberspace. All right. Now we have two questions to answer. When is the Big Bang, and who is the almighty creator of this virtual reality or virtual universe? All right. So the Big Bang happens when the internet was born around 1980s. And who is the almighty creator, or in other words, the God of this cyberspace? So computer scientists and software and hardware engineers, right? All right. So in fact, in other words, we can say that cyberspace are is our kingdom. Yeah, that's funny, but this is the fact. Okay. So now the question is, what is our job? What is the developer's job? The developer's job is to simulate the real world. So if this is the real world, we simulate it inside our cyberspace. Okay, so now the question is, how can we simulate that? Right? I'm not gonna go into the very detail of this stuff, but in a word, we can say, yeah, software's job is to simulate it. So now the question is, what is software? So software is an electronic model of a real-world procedure. So this model goes to the cyberspace. So this model in fact is some kind of simulation. We simulate the real world procedures inside the cyberspace. Let me take an example to clarify that. For example, if you write an accounting program, it means that there is an accounting department somewhere physically, that they have some procedures, and we actually model or simulate the whole procedures of the accounting department inside the cyberspace, and we call that a software. So in fact, software is nothing but a model, a simulation of the real world. Okay, and well, we can say the same thing for the sales department and many other things. Whatever we have in the real world, we can simulate it inside our cyberspace or our virtual universe. Okay, so from etymology point of view, cyberspace was mentioned by American Canadian fiction writer, this guy, William Gibson, in his novel called Neuromancer. I am not sure that I am pronouncing it correctly or not, but for the first time, he mentioned the cyberspace word inside his novel. And he won many, awards. It is a science fiction masterpiece, and they are saying that it is the 20th century's most potent visions of the future, which is a very big, deal here. It's a big honor for this writer. Computational paradigm. Let's see what it is. So, what is paradigm? Paradigm in the dictionary is a model or pattern for something, a theory or a group of ideas about how something should be done. That is pretty, close to whatever we want here in computer science. So paradigm in computer science is a method for modeling and representing of what? The entities and their relationship. So when we say paradigm, yeah, in computer science, we mean we are talking about a technique, a method, right? A way for modeling or simulating and representing of entities and their interactions. So where we are going with these concepts, we have learned that this is the real universe, and we are going to model it inside our virtual universe, right? So paradigm now is a method for modeling and representing these entities that exist here, right? And their relationship. So if we want to model these entities and their relationship, we call it paradigm. All right. And there is a wide application of this paradigm term in philosophy and also the sciences, especially in computer science. Okay, so computational paradigm, uh, in computer science, we have, four major paradigm. All right. So one is the imperative or procedural paradigm, functional paradigm, logical paradigm, and object-oriented paradigm. All right. So uh, I'm going to talk about object-oriented, definitely, because of, this course is about object-oriented, but you will learn more about these three in the programming language paradigms course. Right? So in that course, probably you will learn to compare and to the pros and cons of each one of these paradigms. Okay. So object-oriented paradigm, um, of course, we will be using this in this course, and its job is to model the universe, the real universe, into the cyberspace as we learned so far. And we will be using Java language in this course as our programming tool. All right. In object-oriented, as its name is saying, all of the entities of the real universe will be modeled with objects. All right. So if this is the case, it means that object is the building block of object-oriented programming. But so probably you are asking, so what is this object? Yeah, so our next thing that we should explain is what is object. So if object is the building block of object-oriented paradigm, so it deserved to have its own section. Now, in this section, let's see what is an object. But before that, let's review what we already know about that. So you have learned from your previous courses that object stores some information and it gives some services. So usually I show an object like this egg. It has two separate sections, and in here you store the information, and here you write the services that an object will give you. But in object-oriented programming terminology, we call this information part as attributes, and here this portion that gives you some services, and we call them behavior. In Java terminology, they have different names. So in Java terminology, we call this section as instance variables or instance fields, and this portion is called the methods. So you can consider each method as a service. All right. So now let me give you the official definition of an object. And this definition is independent of programming language. So we are looking at the definition of the object from the object-oriented paradigm, not a specific language. So an object in cyberspace is an entity, and it has three properties. The first property is called state. So each object has an state and behavior and identity. Let me describe each one in detail in the next slides. So what is the state of an object? So we said object stores a piece of information. Where? In attributes, right? So if if you instantiate an object, these probably you will assign some values to these attributes. So this is whatever we do, right? And during the runtime, these values, the values of the attributes I'm talking about, might change. So at any moment of runtime, the object has probably different values for its attributes, right? And the combination of these values is called the state of the object. So state of an object is the set of the values of the attributes at any moment. Now let's see what is the behavior of an object. Behavior of an object is the set of operations or services that it gives to us. Okay, so and as we said in Java, we call them methods. So you can look at every method in Java as a service or as a benefit. Next is the identity. What is the identity of an object? It's a unique name that Java virtual machine gives to your object. What does it mean? So when you run your program, which is written in Java, a software called JVM will run by your operating system, right? Let's say this is the JVM, and that your program will run inside this JVM. So this is your program. Inside your program, you instantiate an object. So this is an object inside your program. And right after that, JVM gives a unique name to it. So this is a unique name given by JVM to your object. And here it's very important that you don't confuse between this unique name and the variable name that you give to your object. So for example, if your class is employee and you, let's say emp1 equal to new blah blah something, so this is the name of the variable that you give to your object. So but this unique name is something else. It's a hidden name and it will be given uh, to this object by the virtual machine. So that's sometimes the source of some confusion. Sometimes you can assign the same object. So if this is your object and this is your uh, variable name, so you can assign another variable that is pointing to the same object. I will explain that in detail later, but for now, I want to make sure that you don't confuse between this unique name and the name that you give to your objects. As I was saying, you can give two different variable name to the same object, but this identity will be a unique name over the JVM. As long as that JVM is running, that unique name will remain unique. Now let's see what is the anatomy of class. Okay, so in the previous courses, you learn how to create a class, right? and you learn how to instantiate a class and create an object. But from object-oriented point of view, we need to ask this question: what is the relationship between the object and class? Okay, so you know how to create object from class, but what is the relationship between these two guys? Okay, so we need to look at this relationship professionally from object-oriented point of view. So we would need a new term to understand that, and that term is called abstraction. Let's see what's the meaning of the abstraction. So let me start this topic from this question that when you uh, when I'll give you a word, let's say for example water, how can you picture that? Is this a glass of water? Is this a river, a pool, lake, ocean? Which one is this? When I tell you the word water, which one do you picture in your mind? The fact is none of them, and probably somehow all of them, right? So when I tell you the word water, the picture in your mind is none of them somehow and all of them. What does it mean? The fact is the brain removes all of the details of these stuff. Yeah. So when you were a kid, so you watched and saw a river, you saw a pool, you saw a glass of water, and you saw probably ocean, right? And your brain removes all of those details and create a generic concept of that. It's a generic picture, it's a blueprint, it's a template of water, right? And this is called abstraction. This operation that your brain does is called abstraction. Another example would be the number of, let's say, five. Any other numbers. Let's focus on the five. How you picture it? Yeah. Is it five, let's say, cars, houses, bikes? Again, none of them. Yeah. Again, your brain removes all of these details from the five cars, five houses, five bikes, and create a picture about the five, which is a generic picture like the water. Again, this procedure is called abstraction. Let's summarize our knowledge. So human, which is us, sees many instances of the water, and the brain try to remove all of the details and create a generic picture of that, right? And the same thing happens for many, many things. And in our brain and in our memory, we have a lot of concepts, and this is called abstraction. So we are not done yet. Abstraction is a big topic. We will get back to this later. But for now, this much is enough for us to understand the meaning of the class. All right. But so I put a note here. This concept and this procedure, this ability of human is so important, without which we should get back to the caves. We are not human anymore. So just keep in your mind that how much this abstraction is important. All right. So now we are ready to understand what is the meaning of the class. So class is an abstraction of similar objects. So we have, let's say, one object, one object, one object, what the similar, of course, right? For example, the employees of a department, of a organization, whatever. So we have, let's say, Ahmad here, Smith here, Barbara here, right? And then when we abstract all of these objects, we can create a class, right? When we remove the specific details of these people, right? We can create a template of that exactly the same way that we understand the water in our mind. But here we are talking about the cyberspace. We are talking about the computer, right? The software uh, part. So here is the example I just took here. So in the payroll, for example, if you have several employees, we abstract all of these, employees and create an employee class. And each employee, so employee one, two, three, whatever they are one instance of this class, right? So in practice, when you are designing a program, when you are writing a program, usually all of these procedures will happen in your mind. For example, if you are going to write a payroll program, right? You as a designer, you look at that department or organization and see, okay, so there are some employees here, and that's why we need a class called employee. So your brain as a designer will do that. So that's called abstraction. All right. So we would need another new term. We call it class members. So what are class members? So if we have a class here, all of those members of this class, I mean, uh, what are they? What are they? So the instance variables, we put it here, some methods we put here, and also we have some nested classes that I will cover later. So probably you put it here. So all of these instance variables, methods, and nested classes, we call them class members. Now let's see what is the class member visibility. So it means that which members can be seen from outside of an object. What does it mean? Let's say we have an object here, right? And we have another object here, and this object is looking at this, the first object. What does it see from these members? So these instance variable, these methods, this is the our focus in this section. What does this object see from the outside of the first object? All right. So in Java, we have full control to tune whatever we want to expose to the outside world. We have full control, and some, you know, let's say most of the other languages like C++ that supports object-oriented, they have this feature as well. All right. So let's see what visibility we have. As you might know, Java has 4 keywords that we call them access modifier. The first one is the public, protected. When we don't mention any access modifier, we call it no modifier. And this is also known as package modifier or default modifier, and also private modifier. So from here to here, when we go from here to here, so this is the least restricted modifier, and this is the most restricted modifier. These two guys are mild modifier, let's say. Okay, let's start with the public one. I will explain them and I will give you a quick demo about them. Okay, so public modifier, as we said, it's the least restricted modifier, right? And when we put this modifier on any class members, the class member can be seen from anywhere. It can be seen globally, right? And we also we can put that on the instance variables. We can put it, before the methods, and also we can put it on the classes as well. Now let me show you a very quick demo about this. So let me create a new project. Um, So the project name would be, let's say, OOP demos. Okay. So in this course, we will be using the Eclipse. I mean, all of my demos will be on Eclipse, and we will be using Java 1.8. All right. This is a simple Java project. So I create a package for our unit. So let's see, call it unit 01 and enter OOP. And inside this package, let me create another uh, package. Let me call it package A. And let me create another package, package B. All right. Let me create a class inside this. Let me call it my class. It's a public class, and I think everything else is correct. All right. And another class here. Let's call it other class A. It means that it is in package A. And finally, we create another class here. Let's call it other class B. Okay, so I'm gonna define something here. Let's say, for example, string name, and also I'm gonna create a very simple, let's call it my method, right? And this, and we are gonna type something. Let's say, for example, my method in my class. Okay, so as you see, its modifier, access modifier, is public here. So I want to show that this guy can be seen in the other class here, which is inside the same package of the my class, and it can be seen here on other class B, which is in the package B. All right. Um, Okay, so let's start from here. For simplicity, I just create a main. So you can create quickly main, just control the space, right? And we just instantiate my class here. So my class, let's call it my class equal to new main my class, and here my class. All right, so you see my method can be seen here, and if you run this, run as Java application, so the method is accessible here. So the method is accessible here in the other class inside the same package. We can do the same thing inside the other class inside another package, right? So if we run this as a Java application, you see this is accessible in from anywhere, all right? Now let's see what would happen if we have private members. So private members are most restricted. So what does it mean? It means that when you put a private modifier, before any members, it can be seen only the same object. So instance variables methods, if they are private, they can be seen here only inside, the same member. And we can put the private on instance variables, on methods, but we cannot put them on the classes. All right. Let me get back to our demo and see what would happen. Okay. Now, in this part, I'm gonna change this public to private and see what would happen here. So definitely it cannot be seen, yeah. And in the other package, again, it cannot be seen. How about no modifier? So the no modifier, as we said, it's a mild or moderated uh, restriction. Okay, so when we don't put any access modifier, uh, it can be seen inside the same package. What does it mean? It means that I will show you on the demo, only the classes that are in the same package of the first class can see its members, all right? And we can put on the instance variables, on the methods and the classes. All right. Now let me get back to our demo and see how it works. Okay, so now we get back to here and we change this private, we remove that. So this is no modifier, all right? And now let's see what would happen in the other class A. No complaint here because this other class exists in the same package. So it can see that member. But how about this guy? This guy is still complaining. It cannot see. So bottom line, if we remove the modifier, it is called the default or package modifier, and that member can be seen only, you know, for the, it can be seen the classes that are in the same package. Another one will be the protected. What is the protected? Protected is very similar to the no modifier or package or default modifier. Yeah. So it's a moderated version, and also it can be seen when the class is located in the same package, right? So it's very similar to that, but there is a very subtle difference that I will cover later. Right now, our knowledge is not enough. All right. So up to this point, you just know that, no modifier and protected are very similar. Both of them can be seen in the same package. The only difference, another difference that they have here is we can put it for the instance variables, we can put it for methods, but not for the classes, right? So default modifier could be, applied on the classes, but the protected cannot be. All right, let's get back to our um, demo, and now we are gonna change this to protected. All right, now when we go here, it can be seen here. How about this? It cannot be seen here. So you see, from this point of view, they are very similar with the no modifier or default modifier. All right, now let's summarize what we learned here. So we have two packages, package A, package B. This is the thing that I just showed you in the demo. So this was my class. This was other class in the same package, and we had another one here, other class B in the package B. And the question is how the members can be seen here. So we notice that in my class members, if it is public, everyone can see that. If the member is protected, only the class A can see, which which is located in the same package. The same thing happened here. If it is package modifier or default modifier, you see it can be seen in the other class A here, but not here. So the same as the protected. And if it is private, so if it has a private member, nobody can see that. All right. And from the point of view that which one can we put where, this table is summarized that public can be put on the classes, it can be put on the instance field and on the methods. So public is so much flexible. When it is protected, it cannot be put on the class, but can be put on the instance variable and method. Package, it looks like the public, it can be put everywhere. And private, no for the classes, but yes for the method and instance variable. So this topic is not complete yet. We will get back to this later, all right? So when we have enough knowledge to talk about that, we will get back to and finish this topic. So I'm gonna stop here. See you guys in the next lecture.